Okay, so now we're going to get properly started on the idea of the binomial expansion and what it essentially means. Now, a way to explain what the binomial formula is actually doing for particular coefficients, I have a little bit of a weird analogy. Now, it might help some people, it helps me teach it, and some of my students have found it quite helpful. So, what we're going to do is imagine. Now, I know some people might not have been around for this idea of Plinko or sort of any sort of coin pusher machines. But essentially, what you have is a triangle of sorts with different pegs. And essentially, what happens is that you have a ball, and the ball is going to fall down some path. These paths we're going to give rows to. So the top we tend to call row 0. The next one down we call row 1, then row 2, then row 3, and then row 4. So note that the row number plus 1 corresponds to the number of pegs that are available. So what we're going to do is we're going to track the number of ways that we can get to each individual peg on the rows. So I'm going to start actually with row 2 because row 1 is fairly trivial. There's only one way to get to the peg on the left and only one way to get to the peg on the right. In this way, we could either go straight down the sides, in which there's only one possible way to do that on both sides. But also note that for this middle peg, we could go left and then right, or right and then left. So there are two possible ways to reach that middle peg. Now, in fact, there is sort of a consistency between each of the edge pegs that are all going to have one possible way to reach them. Now, for the middle one, we could either go two left and then right. We could either go down this way, so right, left, right, or go right and then two lefts. So there are three possible ways to reach this one and three possible ways to reach this one. I will skip over some of the maths and combinatorics for these, but note that there are 4 ways to get to that one, 6 ways to get to that one, and 4 ways to get to that one. Now, note that we can write this in a slightly different way. And this is where actually the binomial coefficient comes in, because this is essentially what it's doing. So note that for the first row, which we indicate with the top number, we move to the left 0 times. And for the other one, we move to the right exactly once. If we continue this down by letting the top number be the row number and the bottom number be the amount of times that we're moving to the right, this is how it works. So here we have row 2 moving to the right no times, row 2 moving to the right once, and row 2 moving to the right twice. Similarly, row 3 moving to the right no times, 3 once, 3 twice, and 3 all 3 times. And similarly, 4 0, 4 1, 4 2, 4 3, and 4 4. Now, note that if you were to type any of those in as if it were a binomial coefficient, you will actually get the number of possible ways that you can reach that row. So what we can note is that generally speaking, this idea of the n choose r binomial coefficient essentially means on the nth row, we want to move to the right a total of r times. So that's part 1 of the explanation. Part 2 is how we're going to define it, or how we're going to use this concept. What we're going to do is we're going to consider the function a plus b to the power of n. And what we'll do is we'll say that anytime we multiply by a, that corresponds to moving to the left. And anytime we multiply by b, that corresponds with moving to the right. So note that we can express this a plus b to the n as simply a sum of all of the possible ways we can reach that row and each of the individual pegs. So even if this were to the power of 5, for example, the first case would be to consider that we managed to get down to the 5th row, but we don't move to the right at all. So that means we're going to be multiplying by a total of 5 times. Adding on to that, we're now going to consider the next peg over. If we move to the right once, then we have 1 movement to the right, but only 4 movements to the left. A way we can kind of motivate this is even in the case of 4 choose 2. So we move to the right twice, so that means we have to move to the left twice in order to get that exact peg. Then just for the next term, we can have 5 choose 2. We move to the right twice and the left 3 times. And so on. So what we can say is that each individual term in the expansion of, say, a plus b to the power of n is given as the following. N choose r multiplied by the amount of times you want to move to the right times the amount of times you want to move to the left. Now, note that this power of n minus r is there so that these two will add up to the amount of times that we move, or the row number that we end up on. So n minus r plus r gives us n, and note that in each of these terms that is true. So we have a 5 and a 0, 4 and a 1, 2 and a 3. They all add up to the individual row number. And a sum of these will actually give you out the full binomial expansion of anything that you want.